Thank you everyone for joining us. My name is Elizabeth Waite. I am a Regional Drought Information Coordinator for NOAA's National Integrated Drought Information System. So today in the webinar, I am going to provide a brief overview of NIDIS, the National Integrated Drought Information System, and the Intermountain West Drought Early Warning System. And then we will have a presentation by Royce Fontenot, the Senior Service Hydrologist at the National Weather Service in Albuquerque, New Mexico. He's going to talk about the drought in the Southwest region. And then Mike Halpert, the Deputy Director of NOAA's Climate Prediction Center, will give us more information about El Nino and ENSO, the El Nino Southern Oscillation, current ENSO probabilities, anomalies, and trends. And after Royce and Mike's presentations, we will open the webinar for any questions that you have. Andrea Baer, the National Weather Service Western Region, will facilitate the Q&A, and she'll direct your questions to the most appropriate expert. During the webinar, all participants are muted, except for those who are presenting. So all participants are muted. So if you have a question, please type your question into the chat box, or you could also raise your hand in the little GoToWebinar box at the top. But you can type your question into the question box or the chat box, and then Andrea will handle your questions after the presentations. The webinar will go for 1 hour. And if you have any remaining questions after that hour, you're welcome to email me. And also the webinar is being recorded, and the recording as well as a written briefing report of the webinar will be available on drought.gov. So briefly, the National Integrated Drought Information System was established by congressional mayor to provide a better understanding of how and why droughts affect society, the economy, and the environment, and to improve accessibility, dissemination, and use of information for drought risk management. And finally, to build a regional drought early warning system, or a network of regional drought early warning systems to create a national drought early warning system. So today's webinar is focused in the Intermountain West Drought Early Warning System, with a focus on the Southwest drought in the Four Corners area. And now I will turn the presentation over to Royce. And we'll try to do that. Sorry. Okay. And find the right buttons. There you go.
All right, Elizabeth, I've got it.
Great. Thanks, Royce.
All right, good afternoon, everyone in Mountain Time Zone eastward. Good morning to those in the Pacific Time Zone. My name is Royce Fontenot. I'm the Senior Service Hydrologist here at the National Weather Service Forecast Office in Albuquerque. For those who aren't familiar with the Senior Service Hydrologist does, just in brief, I coordinate all the weather services, mainly for the Forecast Office, the hydrologic programs that includes drought. I also cover the El Paso Forecast Office and serve as a state liaison as well. So let's get right into it here as soon as PowerPoint cooperates. So kind of an overview of where we're looking at. 2017-2018 water year ended on September 30th, excuse me. Generally poor for most of the region. We've been talking about this really through the last 12 months or so. Extreme drought remains entrenched over the Four Corners, and we'll take a look at that. We had really good late season rainfall that helped reduce drought conditions over a large portion of the Southwest. Some areas completely knocked out drought off the US Drought Monitor. Other areas wasn't so promising. Early 2018-2019 water year snowpack is promising in many areas of the Southern Rockies and the Intermountain West. And right now, the main impacts from the drought are primarily hydrologic and agricultural in nature. So let's take a look at the U.S. Drought Monitor. This is the current one issued this morning. Data cutoff here is on Tuesday morning, so it was issued this morning. So nationally, we've had a series of heavy precipitation events east of the Rockies. So a lot of the drought in the eastern 2/3 of the United States has been knocked out. But really the epicenter for drought in the continental United States is the Four Corners region in the Intermountain West. This D4 is very persistent. Looks a lot like the 2002 drought. when we're looking back in history. You can see there's some other areas of D3 or extreme drought over central Oregon, parts of northern and southern California. But really, when you focus in, the Four Corners region, it really remains that epicenter of drought. So zooming in on the Southwest, particularly, like I said, again, here in the Four Corners region, you can see that's just embedded and holding in really over parts of, most of it over New Mexico, Colorado, parts of our neighbors to the west of Utah and Arizona. But this has really had an impact on water supply through the year. And I'll show you a little bit later, we've had some really record low stream flows. And of course, this is the West. Water supply is incredibly important. So many of these snowmelt driven rivers have been suffering. So what we've changed since our last webinar back in the end of October, you can see here, this is a change map looking at this morning. It's Drought Monitor, and you can see a lot of the improvements have been over New Mexico. We had some really good late season events that's brought up drought areas out of drought over the middle and lower Rio Grande valleys, parts of eastern New Mexico. Over the last month, we've seen a one-class improvement over parts of the rest of the states, and a lot of New Mexico's improvement was a reassessment over the last 2 to 3 weeks, where we've sat down and kind of looked. Really, monsoon season had wrapped up, early into the winter season, kind of really where we stood. So a lot of those improvements, particularly over southeast New Mexico, were a result of kind of that reassessment. But we can see over the last month, we've had some mild improvement. We had a very wet October, and we'll discuss that a little bit as well. So here's an animation going back to last year. So kind of this drought, we'd already seen some areas of the Southwest, mainly Arizona and Utah, starting at the beginning of the last water year, October 2017, already in drought. And really, October precipitation, particularly over Colorado, New Mexico, seemed to more or less cut off. And so we've built this kind of rapid drought, and you see progressing, here we are in June, coming up through midsummer, that D4 has really expanded over the Four Corners and continues to expand through the summer. So this is kind of a history of how rapidly onset, a lot of this drought onset really within 6 to 8 months, which is going from nothing to D4 drought. That's pretty fast. But winter was very poor, extraordinarily poor, and we'll talk about that here in just a second, in a lot of the mountain regions, which heavily depend on that snowpack for water supply. So looking at 30 and 60-day percent of normal. So October, was pretty wet most of October. Looking in November, on that left is that 30-day graphic, on the right is the 60-day. And the 30-day graphic, you can see there, most of November has been fairly dry over the Southwest. We had a very nice winter system roll through eastern Colorado, eastern New Mexico early in November, brought a lot of that precipitation above normal. But when you look, most of the areas, it was kind of a dry November. Now, when you start adding that October in, you start seeing a better pattern. We had some tropical systems late September, early October that really helped out parts of Arizona, not so much in New Mexico or the Four Corners region. And as I go through these graphics, I kind of want to emphasize that you're going to see on the Four Corners region here, let me see if I can get the pen here to work here. Let's see, the spotlight. The Four Corners region here really stays dry, and that's holding that persistent drought. So, and also another thing I want to remind folks that as we're getting in this time of year, and I've got a graphic later, this is normally a dry time of year in the Southwest. We're in between, we've cut off kind of the monsoon. We really haven't started our winter yet in a lot of the areas. So it doesn't take much to skew some of these statistics. But either way, looking over the last really November, late October, early November, that really has helped us on grade at Crystal Mountains and parts of the Front Range there in Colorado drought-wise. Going back a little bit further, 90, 120 days, 90 days is on the left, 120 days on the right. You can see a lot of eastern New Mexico, parts of Colorado did get a lot of precipitation there through the monsoon season. Obviously, Arizona, with the impacts of the two tropical systems, really helped bring up that precipitation, parts of Utah as well. But as we, again, focus in on the Four Corners, getting further and further behind the precipitation. So really, how dry? So this is a product from our colleagues at University of Idaho and the Western Regional Climate Center from the West Side Drought Tracker. So this, and using the PRISM data, which is a precipitation data set from Oregon State University. So this really puts things in kind of context to itself. Really, how dry are we talking? So how dry in a dry land? this area of the nation is not a very wet area of the nation. So just how dry were we? So looking at kind of May through October, which is May and June are drier months, but really again in the monsoon season, you can see a lot of western Colorado, and again zooming in that Four Corners region, extraordinarily dry, near some of the driest on their record. And as you go through even longer time period, going back November 2017 through October 2018, record driest for some of these areas. So really, again, when the precipitation stopped, it stopped, and that had a huge impact on water supply, particularly in local municipal water supplies in the Four Corners region. So here's another product we like to show. Often you'll see us display a product called the SPI, the Standardized Precipitation Index. This is a variant of that. It's the Standardized Precipitation Evapotranspiration Index. And if you go back to your science, evapotranspiration is a combination of evaporation and transpiration from plants. So basically, if you want to think about it, it's the environment's thirst for water. And looking at the October 2018, this data is only updated monthly, so we'll have some new. You can see parts of the Four Corners were right near normal, a little bit below, but most of the rest of the region was moist and cool. Which was great, kept evapotranspiration demand down. We had a really nice October. That's something we've rarely seen recently. But let's get back to the 3-month period, again, focusing on the Four Corners region. Eastern New Mexico did great. Parts of Arizona did great. Again, you have a lot of rainfall. That's going to skew those numbers away from dryness, less evapotranspiration, but the Four Corners remained warm and dry. And what's great about this method, it allows you to compare apples to apples, so to speak. So when we're talking about a weather station's record, we're looking at that weather station compared to itself, compared to the same period of time. What's this 3-month period of time look like in comparison to the rest of the record? Moving that further out to 6 and 9 month there, again, that pattern, the Four Corners region remains dry, really all western Colorado, parts in New Mexico. Going in the 9 months, you see that intensify. So again, I love to compare drought to malnutrition. The atmosphere and the environment expects a certain amount of precipitation, even in the desert at times of the year. So the more you go without precipitation or food, if you want to think of it that way, the more starved you get. So as we're showing the SPEI, what this is really telling you is kind of the starvation of the ecosystem, really how malnourished this really is. And you can see growing in the longer periods out, particularly the Four Corners, it becomes very malnourished. Of course, what happens when you become more malnourished? It takes more energy, more food, more calories to get you back up. So that's kind of what we're dealing with precipitation. We'll talk about that more. So going to the 12 month, and that's really what we're looking at. We're now into the longer term drought, 12 to 13 months. You can see that Four Corners region is very, very dry. I mean, that's really kind of statistically at the low end of it. Another product I'm showing on the right, which does update more frequently, it's called the EDDI. This is from a NOAA lab up in Colorado. And this is the Evaporative Demand Drought Index. It goes back to measuring the thirst of the atmosphere. And we put this in the same context and same look as the US Drought Monitor. So you can kind of visualize it a little easier. Again, 12 months, we're in that category 4 there, that extreme, this is extreme for its period of record. So again, high demand for moisture with little available. So timing also matters. So this is a graphic on the left here. I'm going to start this animation from the Colorado Climate Center using data here. So as it rolls through, and we'll let cycle through, what part of the precipitation in a particular month, what contribution does it do to the total for the stations through the year? So as you focus in on the Four Corners and the Rockies, you can see a lot of the contributions this rolls through the cycle of the year is the monsoon season. Certainly high elevations, particularly in the Rockies, parts of the San Juan Mountains in New Mexico and the Sangre de Cristos, as you're going through, they definitely rely on that winter precipitation. That's the bulk of their precipitation. But as you get into the summer here, look into the Four Corners region, they need that monsoonal moisture to make up a lot of their moisture. So we started off the water year, going through late 2017, early 2018 with very little moisture. We really had no snowpack. So, the hope was somewhat, hey, we're going to have, monsoons coming and maybe this will be a great monsoon and help us kick up. And sure enough, you look at the standardized precipitation index, again, this particular index, just as precipitation, you can see the Four Corners region, when they most needed that rainfall, was at some of the lowest, if near record, for a lot of those stations. So, as we're into this year of drought in the Four Corners, so to speak, when they really need that precipitation in the monsoon, it didn't develop. So So head on, what is our snowpack currently? So we've already entered winter a little bit early. Matter of fact, in southwest Colorado, Wolf Creek, we had a very early season October snow event. Wolf Creek was the first ski resort to open. So this is as of this morning. This is from the NRCS, the National Natural Resource Conservation Service. They're the part of the USDA that monitors snowpack through the United States. And right now, looking over right at Colorado, the Front Range is doing really well compared to where they should be right now. Most of the snow water equivalent, which is if you melt all that snow sitting in the mountains, melt it down, is running well above normal. Northwest Colorado doing, upper Colorado headwaters doing fairly well above normal. But that southwest part, Gunnison's near normal, but San Miguel, Dolores, Animas, San Juan basins, and the upper Rio Grande basins are running a little bit below normal. Now, we had a really great start to the snowpack, well above normal. If you had looked at this 2 weeks ago, you would have seen numbers pushing 200, 250% of normal. We've had a dry November so far. I have not had a lot of new accumulating snow. So you're seeing that impact. You're seeing the same thing over in New Mexico on the west side basins, the Rio Chama and the Jemez River, which feed into the Rio Grande, where opposite the Sangre de Cristos, we had, again, that east side snowpack that really helped that up. So we've had a dry November. We had a good start to the snowpack. But so far it's holding. So these numbers are decreasing, not as much because we're seeing a decrease in snowpack. We just haven't had any new snow during this last 30 days or so, or not significant. So as we look over at Utah and Arizona, we'll look over at Arizona first. In the Flagstaff area, looking really good right now, currently above normal. But again, those are higher elevations as you go a little bit further to the east. Looking at parts of the San Francisco and the Gila Basin, the Little Colorado, snowpack not doing really great right now there. Utah's a very mixed bag of snowpack data. So southeastern Utah, not doing very well at all. Northern Utah, when we talk about reservoirs, you can see are doing quite well, near normal on snowpack. But even in the Salt Lake City area, you can see there, it depends. Some basins are doing much better than others, even when the short distance there. So again, the main impacts we're talking about is hydrology here. So looking at the 28-day stream flow, this is from the U.S. Geological Survey. Again, this is relative to the last 28 days. Where does it stand? A lot of the gauges are looking pretty good. Pecos River in New Mexico is looking pretty decent. They've had some late season precipitation there, but I want to focus on New Mexico, in particular, upper Rio Grande Valley, with that north central part of the state, and then the northwest part of the state, the Four Corners region, again, well below normal. Just didn't get the snowpack last year, didn't get as much of the rainfall. So that base flow, that water that should be there, is well below normal. Looking over Arizona too, again, a mixed message there. Those areas that really got a lot of the precipitation in October are still showing near normal stream flows. Those areas, some that didn't, are still showing well below normal. Looking north into Colorado and Utah, we're seeing the same sort of trends there. The eastern Colorado, is doing very well. Had some great late season events. Western Colorado and a lot of southeast Utah in particular are just well below normal. Again, this is normally a low stream flow time of year. Winter's starting back up, summer's done. But even then, so what you're seeing here is that the soil moisture in a lot of these areas have been just depleted. They just didn't get it. Rivers are well below base flow. As an example here, particularly probably two of the hardest hit rivers, the Rio Grande and Butte. This is northern New Mexico. It's an unregulated spot, not really, not a lot of regulation above it. Those on the right, those orange triangles are where the river should be. You can see it's well below where it should be for this time of year. Same thing with the San Juan River at Four Corners, Colorado. That's going to be the Animas River, the San Juan, several other rivers going through there. Again, well below normal. And particularly in the Four Corners region, this is where we've seen issues with municipal water supplies. They had some severe water restrictions in some of those villages and towns through there. So soil moisture, something we talk about often. This is a product from our colleagues over at NASA Sport over in Huntsville, Alabama. On the left is a 1 month change. This is looking through the top 2 meters or so of the soil. So it's a combination of remote sense data, radar, satellite, with a soil moisture model. And we can see over the last month, the effects of that not having having a kind of dry 30 days. So you're seeing that drying trend, and these are only 2 to 4% of loss of soil moisture in the last month or so, but you still see that drying trend, and just how much that we're already short of soil moisture, just how much a dry month will impact. But we're seeing an increase in some of the mountains there in the last month. Again, that's because of the early season snowpack. Looking on the right, the 6 month change, we did get some improvement. A lot of these areas, the higher end, near 15 to 20% increase. particularly over parts of Arizona and New Mexico. The drying you see primarily over the Rocky Mountains is due to snowpack, what little there was last year, going away. 6 months back, we're looking at May, June. A lot of that snowpack was already going at that time, so you were losing some soil moisture. So again, reservoir storage, kind of a big thing out here in the West. So this is as of November 1st, where those reservoirs are standing. Almost all reservoirs through the Intermountain West are below normal. There's a good below normal for where they should be this time of year. There's a number that are where they should be. For example, in New Mexico, Santa Rosa on the Pecos is where it should be for this time of year. However, Elephant Butte, and we'll talk a little better about that, is down to 6% of where it should be. Looking at Arizona, I think San Carlos is one that stands out at 4%. Lake Powell, which affects Arizona and Utah, part of the Colorado system, about 59% of normal where it should be. Colorado, Blue Mesa is a very important reservoir. It's very sensitive to snowpack. It's also a very large reservoir. It's the largest in Colorado. It's at 41% of where it should be. Conversely, John Martin on the east side of the state's doing really well, 133%. And Utah, again, kind of this mixed message here where some are well below normal. Flaming Gorge and Strawberry in the northern part of the state are doing pretty well. So kind of going through this, some graphics from our colleagues at the Colorado Climate Center and putting things in perspective where they should be. They're using 1985 to 2016 as average, but on the left there you see Blue Mesa. And that black line is where it is currently, and it's well below the minimum 10 percentile. But if you look 12 months ago where we had a really great snowpack in 2016, 2017, it was right there at the top. Really did very well. So really we have, within 18 to 24 months, almost a complete reversal. Lake Powell there you can see is in the minimum 10 percentile for the time period. Navajo Dam, same thing, down in that 10 percentile where it should be for the time period. Flaming Gorge doing quite well up in Utah, running there at the upper part around 70 percentile for its overall time period. So Elephant Butte, this is a particularly important reservoir. The Rio Grande Compact, it's part of the Rio Grande Compact between Colorado, New Mexico, and Texas. So this is where it's looking at. Where we're sitting right now, these graphics are from the Texas Water Development Board. That red line at the top is the flood pool. That's where the reservoir is full, the dam is spilling. The blue line's where we are currently. Last year, again, we had really great runoffs. 2016, 17, it gotten up 500,000 acre feet, and we kind of were there too early last year, but that went out pretty fast. So where we put that in context, where we should be here. These are the last 3 years plus the minimum and maximum from 1990 through 2017. And you can see that dark blue line with the diamonds. There we are. We're well below what the median value is and the min max for that time period. So where does this really stand in context? So let's go back even further. Elephant Butte opened in 1915. So again, you can see there was this massive amount of storage in the starting in the mid 70s. Really going through late 70s, going through the mid 90s and early 2000s in Elephant Butte. Several times the dam actually spilled. But context-wise, where we are, the last 3 months at Elephant Butte, have been below 90,000 acre feet. The last time that happened was 1978. So we're seeing levels at this time of year that we haven't seen in 40 years at Elephant Butte. And that's a combination of long-term drought, and short-term drought. We, like I said, had a very wet period there, but relatively where we are at Elephant Butte, the levels we haven't seen in 40 years. I want to run through these quickly. Kind of the rest of the area here, you can see these are what's called teacup diagrams. So Lake Powell in particular, it's at 43% of its total capacity. Navajo at 52%. Blue Mesa down to 30% of its total capacity. Again, a mixed in the Salt Lake City area, kind of outside of our main focus, but you have a mixed message there. Some reservoirs are doing much better than others. Looking at the Rio Grande, total storage and this data is as of yesterday, is at 4%. Avalon Dam is showing 0%. That's due to a maintenance issue. They've actually emptied that dam. And you can see again, zooming into the San Juan River Basin, and this is kind of important. This is in that D4 area, and a lot of these towns in that area, particularly in New Mexico, Aztec, and Farmington, depend on a lot of the stream flow. So Lake Nighthorse is at 97% full. That's good for water supply, for drinking water in Aztec and Farmington, New Mexico. But we see Navajo's down to 52%. So the other main impact through the Southwest has been agriculture. This is the interior Southwest. We're ag dependent. So the two crops, these are both interdependent, hay and cattle. So you can see there the red hatched areas are the areas currently in at least D1 or greater drought. So kind of the message here is these two are connected. So cattle need feed. Often it's native forage, which has not done well when you don't have rain for prolonged periods of time, over 100 days in some cases. Even native plants start to die off. So we've had a lot of agricultural issues where, for example, the feed for a lot of New Mexico cattle comes from southern Colorado, from alfalfa fields in the San Luis Valley, which is that upper part of the Rio Grande Valley. Alfalfa crop failed in a lot of areas, so feed became short. So we really had an ag impact, particularly in cattle and hay production through the Southwest, due to the fact that the native forage has been poor, hay production has been poor, water supply has been poor. So there has been a lot of impacts there. Earlier in the year, we had some impacts in winter wheat, particularly in eastern New Mexico. Those seem to be doing better this year. So kind of wrapping up here, one question I get is, so what do we need to get out of this drought? And I'll let my colleague at CPC talk about kind of the forecast, but this is one drought index we use, the Palmer Hydrologic Drought Index. It's an older index. It's good for looking at historical data, and no one index describes drought perfectly, which is why we came up with the Drought Monitor. But you can see here, putting in context, these are climate divisions, so grouping a lot of areas together by their climate. You can see Western Colorado, the Four Corners region, by the Palmer Hydrologic Drought Index in extreme drought, very, very low on the index. So you can also calculate how much you would need to make that index get back to zero. Again, doesn't mean necessarily out of drought, but it's a good representation of kind of what is needed. So you're looking at this area, in the Four Corners region over the next 6 months, as an example, we would need pushing 167 or more % of normal precipitation over the next 6 months to bring that index to zero. So again, no single drought index solves all the issues and completely describes drought, particularly in the West. But this is a good representation of the magnitude of precipitation we need to get those areas out of drought over the next 6 months. Essentially, you need, all you would normally get plus 60% more. So it's good relative description of where we are. So kind of wrapping up here, again, 2017, 2018 water year for a lot of stations was poor or near lowest record through the region. This has had a lot of impacts on agriculture and water supply through the region. Extreme droughts remaining entrenched over the Four Corners. We were hoping for a good monsoon season. It didn't happen in that area. So, they've missed a lot of that precipitation they would normally get during that time of year to bring them near normal. Late season rainfall, certainly October, helped produce drought conditions over portions of the Southwest. We've seen drought actually come out of a lot of areas in Colorado and eastern and southern New Mexico. So far, early snowpack in 2018, 2019 water year is promising in many areas. And again, those main impacts right now going into the new year are primarily hydrologic and agricultural. Water supply is down. A lot of the agricultural industry has taken a big hit. So that is my final slide. There's contact information, and I appreciate everyone's attention. And it's back to you, Elizabeth.
Thank you so much, Royce. That was an excellent presentation with lots of great, if somewhat depressing information. Thank you. And now we're going to turn over to Mike Halpert, the Deputy Director of NOAA's Climate Prediction Center.
Okay, thank you, Elizabeth. Hopefully you can see my screen.
Yes.
I will try not to be as depressing as Royce was during his presentation. I will give an update as to where we stand with regards to ENSO. I'll give a little background on ENSO, and I'll end with our seasonal forecasts for both December, January, and February, as well as January, February, and March. So currently, we are in an El Nino watch. So you can see up at the top, there's kind of, we have an ENSO alert system that's broken down into 5 categories, ranging from advisories, which occur when we're in an El Nino, to a watch when conditions are favorable for El Nino to develop, and then that period in the middle, which is the alert system isn't active because basically things are normal and we expect them to stay that way. We've been in on an El Nino watch now since I think it was June or July, which is a fairly long period of time to be in a watch. I will acknowledge when we first started issuing it, we really expected El Nino to develop by this point, certainly. We still do think it will form, prior to or very shortly here as we head into the winter of 2018-19. You can see on the slide there's an 80% chance for that. And we think once it develops, it will last at least into the spring, roughly 55 to 60%. For the Southwest, it's obviously important. While it's not your main rainy season, it is still a secondary one. And oftentimes during El Nino winters, we do see wetter than average conditions as well as increased snow in the mountains. And while we don't issue a snow forecast, I will show a few slides towards the end on at least snowfall associated during prior El Nino events. So just for folks who are not completely aware or understand what El Nino is, this is as simple as we can break it down. This is just looking at the oceanic perspective of El Nino. So if you look at the bottom there, you'll see those reds indicating that sea surface temperatures are above normal in the central and eastern part of the basin. One thing that's interesting, if you look into the western part of the equatorial Pacific, you'll see that warm tongue basically does not continue into the western part of the basin, and it's normal and even below normal around it. That's again, these are that's what we saw back in during the very strong El Nino of 97, 98. So this would have been December. The top again, La Nina, is just the opposite. So where are we today? This is a 4-week average of sea surface temperature anomalies or departures from normal across the Pacific Basin. So where you can see Australia in the lower left corner, South America along the right edge. And so the first takeaway really is that there are oranges really spanning pretty much the entire Pacific Basin on the equator. At least from about 150 east all the way to the South American coast. The largest anomalies or departures are in the east central Pacific from about, say, maybe 90 west over to 150 or 160. So, I mean, that would certainly meet our definition of El Nino, and the crude or the simplest definition is when anomalies in a particular region from 120 to 170 west. And so I'll just move my cursor, kind of highlighting where that is. Average above a half a degree. And certainly if you were to do that integration in your head, this whole area is at least a half a degree above, and the oranges are one above. So probably well above that threshold. So the ocean is certainly on the warmer side. It's actually been this way for at least a couple of months right now. Typically, El Nino will last 9 to 12 months. Again, this is in a very kind of an average type sense where they'll develop sometimes as early as mid to late summer, oftentimes in the fall. We'll see potential impacts on the hurricane seasons in both the eastern Pacific as well as in the Atlantic. But really not huge impacts on temperature and precipitation over North America. As we get into winter, that's typically when the biggest impacts occur, and this is really why we have such an interest in El Nino. It forms a big backdrop for predictive skill on seasonal timescales, in particular during the winter. And then finally, as it weakens in the spring, we oftentimes will see a lag of impacts into the spring. And really that's on temperature and precipitation, certainly drought. This is again in its average sense. We've seen El Ninos that have lasted for longer than 12 months, and we've certainly seen some that have lasted for less than 9 months. So again, this is a very broad type of an average. Again, in a schematic sense, you'll see on the reason why, again, we're so interested in El Nino is that what goes on in the Pacific Ocean and the tropics will impact the jet stream across the Pacific Ocean. And given the location of the United States, changes in that Pacific jet stream oftentimes lead to changes in temperature and precipitation. Again, in a schematic sense, and this is probably a better representation for stronger events, but we do oftentimes see the Pacific jet extends really across sometimes the entire southern part of the U.S., resulting in wetter and at once upon a time colder conditions. Now maybe not so much, with a tendency for drier and warmer conditions across the north. Again, a schematic, as it says on the bottom, every winter, every El Nino winter is different. That's why our forecasts, when I show them, are done in terms of probabilities. You know, folks would like to argue, or we've had a lot of scientific discussions here. For folks that stay on top of El Nino, they're certainly aware that in 2015-16, we had, you know, one of the probably 3 strongest events of the past 50 years, and yet we didn't see the typical impacts. You know, certainly when I'm showing the schematic here, that's not what we saw that winter. And you know, our forecasts again are done in probabilities because we can't make any guarantees, even giving a strong event. And one thing I didn't say up front was that even as this El Nino we believe is developing, we certainly do not see anything certainly developing in the range of a 2015-16 event. So what kind of are the links between what goes on in the tropics as well as what goes on in the mid-latitudes or over the United States? You know, I like to tell folks that if the only thing that El Nino did was change the temperature of the water across the equatorial Pacific, we probably wouldn't have that much of an interest in it here in the United States. Certainly in the equatorial and range and in the tropics, they would care. But there's not a direct impact from the ocean changing. What happens though is as the ocean warms in the central and eastern part of the basin, and here's an example from, again, one of the stronger El Ninos. I think, again, it's 97, 98. This is the left picture. But all those greens east of the international dateline along the equator shows enhanced rainfall, and the browns over Indonesia and the Western Pacific drier than average rainfall. And it's these changes in tropical rainfall change the patterns of heating into the atmosphere, which really influence that jet stream across the Pacific Ocean. So it's really these changes in tropical rainfall that we care about. And really, if I were to bring up the precipitation pattern for 2015-16, it was not as clean cut as this. And that's one of the things that we're trying to diagnose and understand why not. On the right side here is a representation of tropical rainfall. It's what we call OLR, or outgoing long wave radiation anomalies. Not that important to understand that, except that the areas that are in blues are typically areas that are wetter than average. Yellows and reds are drier than average. And so you can see, at least over the past 30 days, it's been on the wetter side along the equator, between about 140 east and maybe 170 east, so to the west of the dateline, and just white all the way across the rest of the way, meaning that convection or rainfall in that area has been rather normal. Some of that, when you go into the eastern part of the basin, normal is basically 0. So you can't have less than 0, certainly. So that's one reason why it's white. But even the area around the dateline right now has been normal, but has not been enhanced. And that's really what we're looking for, and that's kind of been the missing piece so far as to why we are still only issuing El Nino watches and not advisories. So here's our schematic. This is from an ENSO blog post that was done a few years ago as to how we assess the state of the tropical Pacific and determine whether we're in El Nino Watch, El Nino Advisory, or neither of the above. We start with a very objective, simple case up in the upper left corner, just looking at the monthly sea surface temperature departure in this area that we term Nino 3.4. Has to be at least a ½ degree C above average. And certainly we've met that in October. I don't remember if we met in September. If we didn't, we were close. So we take a yes and we go to the next box. And then one of the kind of the hallmarks and why El Nino works in terms of providing predictive skill on seasonal timescale is the fact that El Nino doesn't come and go like with a drop of a hat. So if we have an El Nino, we know that it's going to persist 6, 9 months, maybe a year. So when the ocean becomes warmer than average, we kind of then start looking into forecasts, and do we think that it will persist some minimum amount of time? If the answer is no, then we certainly do not have El Nino. If we say yes, we get to kind of the last step, which is we look into the atmosphere, because again, El Nino is not just changes in the ocean. It's what we call a coupled ocean atmosphere system. And so those changes in the ocean need to have the atmosphere responding to those changes. And we talk about it here on the slide, indications of a weaker Walker circulation. That's not really that important what we call it, but in the simplest sense, we should be seeing more rainfall over the central and maybe eastern part of the Pacific Basin and less rainfall over Indonesia. As we just saw on the previous slide, we're not seeing that. So at least currently, we do not have an El Nino, and that's why we continue to have a watch. That product will be updated when we assess El Nino. It's done once a month. Again, this is not something that changes that rapidly, that it needs to be done more frequently than once a month. So we will be reassessing. It's always the second Thursday of the month, which I believe in December is December the 13th. And we will see as to whether we're starting to see changes in the atmosphere over the next couple of weeks, as well as what's been going on recently. So these were the probabilities for El Nino that I kind of alluded to in my opening slide. This is done by a team of forecasters, largely here at the Climate Prediction Center, but we do have one individual up at the GFDL, the Geophysical Fluid Dynamics Lab in Princeton. And we have another person who sits up at Columbia University. The team is, again, you're talking better than an 80% chance of El Nino. So that's pretty high shot that El Nino will develop over the, really even as soon as the next release on December 13th. And persist, and we really expect it to last once it develops, certainly through the winter and potentially even through the spring. So when we have El Nino, people like to see, okay, so what does that mean for temperature and precipitation over the U.S.? Simplest way to do that is to look at all of the prior El Nino events. Look at what the patterns of temperature and precipitation were and average them all together. And that's what we're looking at here. We call that a composite. This is somewhere between 20 and 25 events. So this includes the real strong events of 82, 83, 97, 98, 2015, 16, as well as some of the weaker events, 2006, 7. I could name them all off, but certainly the composite is potentially dominated more by some of those stronger events. In terms of departures, you can see the signal certainly strongest, really surprisingly maybe all along the Pacific coast, and that's really contributed to by some of those really strong events. A tendency for above average precipitation certainly in at least Arizona and New Mexico, maybe parts of Colorado, and then along the Gulf Coast and up the East Coast. Temperature, this might be a little surprising to folks because there's quite a bit of blue on the map, and so certainly cold winters are used to be associated with El Nino. Even into the Southwest, we oftentimes saw below average temperatures. But interestingly, and folks certainly are aware that the climate in just a general sense has gotten warmer over time. And when you add in the trends for roughly the past 15 years to that ENSO composite, you can see that pretty much nobody is left favoring below average temperatures, and really along the northern tier and much of the West now favors above average temperatures. So this is the December, January, and February outlook that was issued in November. Again, they're done in terms of probabilities. Each point on the map has a chance of being below average, near average, or above average. So one could correctly say that that this forecast is never correct, never completely right or wrong, and that's the nature of a probabilistic forecast. But for DJF, I have a little kind of helpful point out here that like in northern New Mexico, it's in the roughly a 42% chance that it'll be a wetter than average winter. That middle category on a seasonal outlook typically stays at a 1/3 chance. And so if it's more likely to be wet, it's less likely to be drier than average. You could view this as saying there's a 75% chance you'll at least have normal rain and snowfall in that part of the country. The temperature chances, again, are lean on the warm side, not overwhelmingly so. The best chances for a warm winter are actually up in the Pacific Northwest and in the Alaskan Panhandle, but still a slight tilt towards above average temperatures in that northern New Mexico area. Again, that was just selected for a helpful hint. Let me see. The Drought Outlook, again, this was the seasonal one issued the same day on November 15th. So the Drought Outlook starts with what the Drought Monitor looked like effective November 15th and projects as to how that will change. So it's basically a tendency forecast over these roughly 3.5 months. So given that we are favoring above average precipitation over much of the Southwest as well as California, we do see improvement in at least the remaining drought areas in Arizona and New Mexico and in southern Colorado, particularly around the Four Corners area. Most of that, there will certainly be drought remaining, as Royce pointed out. You don't typically get out of D4 drought in a couple of months. I mean, we would need maybe not historic amounts of precipitation, but certainly in the upper bounds of what we've seen in a DJF or December, January, and February season. Further north in Utah and in Colorado, we do see drought persisting. Some of that is maybe a little misleading. I think some of these are the part of this has to do with the fact that precipitation that falls as snow doesn't necessarily improve drought until it melts. So this could be the kind of thing that when we issue our next drought outlook for a seasonal one, and that'll be I guess December 20th, and it'll run through March. We're likely to see, assuming we're still anticipating a wetter than average winter, that we're likely to see at least more improvement in those parts of the country. Again, we do issue seasonal outlooks that go out a year into the future, so I'm also showing January, February, March. Somewhat similar to December, January, and February. I guess it's not as relevant for the folks on this call, but the California signal, we are less bullish on a wet January, February, March than we are, largely because December looks like it's going to start out on the wetter side, and so we do lean towards a wet December. Actually, I'm not showing these, but at least over the next couple of weeks, we are favoring above average precipitation over good chunks of the Southwest on really all time scales, our 6 to 10, week 2, as well as monthly and seasonal. Finally, a couple of snow charts, since they play such a significant role on water in the West and the Southwest. When we look at roughly the 21 El Nino years, and this only ran up through, I think it was, 2009, so it does not include the last couple of events, or at least the 2015-16 event. You do see a tendency for above average snowfall, in particular in the Front Range of Colorado and in good chunks of New Mexico and at least parts of Arizona and Utah. Interestingly, if you break those 21 years up, and we threw out the middle one for simplicity, but into the 10 strongest and 10 weakest. You can see at least in New Mexico and Arizona, the signal is certainly much stronger with the stronger El Nino years than the weaker ones. Not so much, and the Front Range seems to work with either case, but there is quite a difference when we're looking at the strong El Nino years versus the weak ones. So finally, just to summarize where we are with ENSO, we've had ENSO neutral since last winter's La Nina ended. We've been in a watch now for 5 or 6 months, but it's still rather warm across the Pacific, and we do expect that we'll see some atmospheric response shortly, and that will persist. And then again, that does kind of tilt our forecast for both temperature and precipitation in towards the favored El Nino solution. A couple of links down on the bottom. The first one, our ENSO diagnostics discussion. That's issued. That's the product that I spoke of. That's issued on the second Thursday of the month, when we will, if we are going to upgrade to an advisory, you'll see it in this particular publication. And for folks that don't like to read or maybe too much scientific jargon, although we try our best on the discussion to avoid that, we do have an ENSO blog that has a post that is timed to go out at the same time as this discussion, that's written maybe in a little more plain language and provides a little more information. And with that, I will stop and turn it back to, let's see, does it go back to you, Andrea, or should it go back to you, Elizabeth?
It will come to me, Andrea.
Okay.
So while Elizabeth pulls up a slide with lots of great links on it, which will be available to you with the PowerPoint that Elizabeth will send out, please type any questions you have for Mike or Royce in the questions section on the little pop-up bar that goes with GoToMeeting. And I'll wait just a minute and see if you guys have any. Looks like we had a few people with audio problems. I think those on the phone were probably okay, but those who did it through the computer, looks like there were a few.
Sorry.
Okay, I'm not seeing any questions yet. Okay, here we go. All right, first question, does El Nino affect the formation of atmospheric rivers? And may it cause extreme precipitation events?
That's a tough one. I would say, that certainly a good chunk of the rainfall for California are associated with atmospheric rivers. A lot of times those are related to shorter term phenomena. Typically, the impact of El Nino is on that jet stream across the Pacific, and embedded in that jet stream, you could have what you folks would call an atmospheric river. It doesn't necessarily make more of them, but it maybe helps to focus them in particular regions, and certainly, having the extension of the jet stream would mean that your atmospheric rivers are more likely to reach the country, as opposed to those winters that we have what we call ridging or high pressure set up over the West Coast, in which case anything that might come towards the U.S. ends up kind of gets deflected, oftentimes up into Canada.
Okay, thank you, Mike. Any other questions? Give it just a minute in case someone's typing. It does look like a few people. Oh, yep, still typing. Okay, we've got a question coming soon.
I think I see one, although my window is incredibly small to look at this.
That is my problem too.
You have that?
Yeah. Okay, here is another question. Can you talk a bit about what the forecast is looking farther north in western Colorado along the I-70 corridor and to further north if an El Nino develops?
Well, again, the forecast, and I've put it back on the screen, although I don't know whether I believe I'm still sharing my screen unless somebody disabled that. So the forecast really over all of Colorado does tilt towards a wetter than average winter, but it's less confident or lower probabilities than over New Mexico. And I'm not exactly sure where I-70 is, but it's actually fairly uniform over the state. In terms of snow, certainly it looks like the eastern part typically sees more snow with El Nino. As far as I think the rest of the question was, should El Nino develop? And the reality is that these forecasts were produced with the expectation that it would develop. So should it not develop, then I guess we could argue that these probabilities towards wet are maybe a little high.
Okay. The next question I can answer. Yes, this information will be available. Elizabeth will put the link up on the drought.gov website, and so the video presentation will be available. And also, Elizabeth, correct me if I'm wrong, but I think you also put the presentations up there, so somebody will have the physical presentations if they would like.
We do put the recorded webinar on drought.gov, and I will also send out to everybody who has participated, who has joined the webinar, I will send you the direct link for the webinar recording because it can be a little challenging to find it on drought.gov. In terms of the PowerPoint presentations, we do not put those on drought.gov, but you are welcome to email me at elizabeth.wait, that's W-E-I-G-H-T, at NOAA.gov. Can you all see the drought resources slide that I think I'm showing?
Yes.
Okay, so at the top of that, you can see my email address, elizabeth.wait@noaa.gov. And you are welcome to email me, and I would be happy to send you the PowerPoint presentations. We just don't put them up on drought.gov. And also after the presentation, we do a 2-page synthesis of the main points of the webinars and the presentations, and those will also be available. The 2-page document will also be available on drought.gov.
Okay, thank you, Elizabeth. Our next question comes from Mary. If a weak El Nino forms, is it likely to miss the 4 corners?
Well, a weak El Nino is probably the best that we're going to see this year. We certainly don't see anything strong, and given that we're approaching December and we're still kind of waiting on the atmospheric response, probably what we'll see will end up to be maybe later on during the winter. As far as missing the 4 corners, again, the forecast itself is issued, based on the El Nino forming, and so that whole region we do favor, not with huge confidence, but we do favor it to be wetter than average. I will say again that at least in the short term, and this is probably not even related to this developing El Nino, but we do see, really in the next couple of weeks, as well as I suspect for the December forecast, we do see, a tilt or better than even chance of it being wetter than average. So at a minimum, it looks like winter will start off on the wetter side for really much of the Southwest.
Okay, thanks, Mike. I think this one, Royce, is yours. You showed maps estimating ag drought impacts. Are there similar assessments for municipal water supply risk from drought?
Not that I'm aware of. Those a little bit harder to assess. A lot of the ag stuff comes from the National Ag Statistics Service. So, you would have to get data. It probably would be more on a state level. If you email Elizabeth, she can hit you my email address, and I'll take a look at that and maybe we're particularly looking at. I know here in New Mexico, there are some state water assessments. And often that is included in either a state or county level hazard mitigation plan. That's something required by FEMA. So they may have some assessments there. I haven't seen anything large scale map wise. I'll do some checking, but if you email Elizabeth, she can get you my email address and I'll take a look.
Thanks, Royce. Next question, is the atmospheric response slow to occur this year? If so, do we know why, Mike?
It probably is slower than we thought, although that might just be our expectations for it. I think one of the things that we maybe should have realized was that this was going to be a weaker type event. And typically, the weaker type events are fighting. There is what we call an annual cycle in ocean temperatures in the eastern part of the basin. And it turns out that the coolest time of the year, or the minimum in that annual cycle, is in the September-October time range. So while the sea surface temperatures are above average, they're kind of fighting the fact that we're at the minimum. So we really haven't warmed the ocean up enough, maybe, to impact the atmosphere. It's kind of been a mixed bag looking at previous weaker episodes. Sometimes, we don't really see an atmospheric response until January and February, although some of the other weaker ones, I think 2006-07, which was the last week of that, things did, as we say, couple, and we did see an atmospheric response really starting back in October. So, it seems to be a mixed bag, and I don't have a real good explanation as to why we haven't seen really an atmospheric response lock in yet.
Okay, and then I will do one more question. Traditionally, drought monitoring and assessment has focused upon precipitation. We're seeing more and more influences as a result of timing and temperature in addition to precipitation. How are we factoring those components into processes moving forward into the drought monitoring process?
All right, it's Royce. I'll go ahead and take that one. So I think a lot of it's evolution of how we're looking at drought as a whole. And it also depends on where in the United States you're looking at drought. Drought ultimately is local. So a lot of our more historic drought indices, like the Palmer dew factor temperature, and some don't, like the SPI. But particularly in the western United States, evapotranspiration is important, which is temperature is a major component of that. So that's something that we are looking at more and more. Like I said, we don't look at one single drought index when we're putting together the drought monitor. Certainly precipitation, drought is basically you're not getting the precipitation you need, but you have to put that in context too, that are you in a time, for example, early last year, October, November, we started seeing 30 days no precipitation, 45 no days precipitation. But here in New Mexico and parts of the Southwest, that's a dormant time of year. So temperature matters. ET is relatively low, evapotranspiration, evaporative demand is low, plants are dormant. So you have to factor that in. So every week, I'm one of the two folks here in New Mexico, principally, that has input back to the drought monitor. We take a look kind of at the whole picture, and certainly that's our approach here, and at least in New Mexico, when we're looking at it, to kind of look holistic. So it really depends. We don't look at one single index. We don't look at one single factor. We try to put everything together. And as a drought monitor states, it's really the preponderance of the evidence. If we lay everything on the table and look at everything, where does it lead in context? So you have to, even when you're looking at drought, it varies from time scale to where you are to time of year. Temperature certainly is a big factor in that. My own academic background is in physical geography, so I kind of look at everything at once. And I'm a big fan of water budgets and temperature and evapotranspiration. So it's particularly here in the West, it's becoming much more of a factor in looking at how we assess drought. But it really varies on where you are in the United States, even in the West, where you are and what time of year and what factors we use for the drought monitor.
Okay. Thank you, Royce, and we're just a tad bit over, so we're going to go ahead and end the webinar now. I would really like to thank Royce and Mike for your great presentations today. And again, lots of good resources on the slide Elizabeth has up on the screen, so please feel free to check those out. And we will be in touch when we are going to have our next webinar. So with that, thank you and happy holidays to all.
Thank you. Thanks, Andrea, Mike, Royce.
Yeah, thank you.
Thanks.
All right. Thanks a lot. Yep. Bye-bye.